Hi guys, good evening. I would like to take a moment to present the second case study, which is visualizing classifier boundaries using kernel PCA, which is a study in dimensionally reduction and classifying classification boundaries, presenting by Vijendra Reddy Mukisa. Beginning to this, I would like to take a moment to show the code and how it is running. In the first, we are importing all the libraries and everything. I'm getting the data from the local directory and reading it using pandas library and displaying it in the DOM. Let's see, there are I have displayed 5 rows here, and in the next step, I'm writing a code there is a code for checking for missing values, and in the next for count how many people have tumors, and next we have features look like they are broken into three major categories. Like here we have we are plotting a diagram like a heat map, and the x-axis we have perimeter mean, area mean, smoothness, and on the y-axis we do have fractional dimensional mean, symmetry mean, and so on and so forth. And coming to the next piece of code, there is a it is also related to a heat map, and the values varies from 0 to 1. When comes down here, yep, the here there is the kernel used for PCA, which classifier will be using here. Like in the case study, these three are focusing. These accept these accepts three inputs, and I think if we are moving down, there is a warning. But these are the linear PCA and RPF poly CA graphs that like uh, uh, validated using that code, which is classifiers and kernel PCAs. And coming down, we have calculated precision recall if one score supported, and this is another logical regression boundary line with linear PCA train set, and this is a test set. This is the train set, and we can see the difference for zeros and ones and the color how it varying, and this is a boundary line we are calculating here. This is for boundary line with RBF PCA. This is for train and this is for test. Looks good here. And coming to this logistic regression for poly PCA, in the same way we do have for sigma PCA and sorry, sigmoid PCA for test and trend for both. And in the same way we have cosine PCA and cosine PCA test and trend. Basically these look like similar for everything, but graph varies for everything. It is Navi based boundary line with linear PCA test and trend. In the same way, we have RBF PCA test and trend. And I am now moving to the presentation. I would like to take from here, which is introduction to PCA and kernel PCA, which is a technique for linear dimension reduction. Kernel PCA extends this by capturing nonlinear structures. Okay, and understanding classifier boundaries. Decision boundaries separate classes in feature space. Kernel PCA helps by when decision boundaries are nonlinear. Kernel PCA uses a kernel function to project data into a higher dimension, allowing linear separation in a nonlinear feature space. Common kernel used: linear polynomial RBF kernel selection. And coming to the data set, I discussed on this in the code, the data set which we are using. And coming to the visualization, classifier boundaries become clear after kernel PCA visualization aids. And coming to the discuss results, kernel PCA allows nonlinear data to be transformed into linear separable features. This is a key point here, which is transforming from nonlinear to linear. which helps in improving classification performance. And when coming to the conclusion, like kernel PCA is more powerful than the nonlinear boundaries. In the future work, we could really include the real world data sets and additional kernel types. And if you do have any questions, like post down to this reply. And thank you for watching this presentation. Thank you very much.